So I've brought in that debris velocity, and now, as you can see, we have these big old plumes of smoke that follow that motion. So this looks a lot better. It's really cool. Okay, well, basically for that, again, nothing too crazy. Third context, debris vel, going to vel. I did a typo on that, so right now it's debis vel, but you get the idea. Let's now move on to a couple of microsolvers. Once we put that in there, then we'll cache this out. I'll talk about how we can use rest fields to add a bit of noise, and that will wrap up the smoke section. So I want to use turbulence to mimic an overall wind. So we'll say gas turbulence. And then I'll also use disturbance, gas disturb, to control detail in general along the voxels and prevent the smooth plumes from occurring. So, gas turbulence. Swirl size, let's take this up. I already know that this needs to go way up. So, swirl size of 10 to start. Let's also be sure that we're using a coarse resolution here for a second. So, 0.15 ought to do just fine. I'll go forward a few frames, and I'm also going to turn on the visualize turbulence. Okay, so if we go forward, we can kind of see what's going on, but not really. Let's go ahead and just, turn off that density. Now we can actually see the turbulence. Okay, and then from here, I'm going to turn up the scale. So we'll go a bit like that. We'll take our pulse length, let's say 0.5 is still all right. Turbulence, let's take that up to about 5 or 6, and then take the grain up a little bit as well, so that we end up somewhere around there. Okay, so also don't forget that we're using OpenCL, so Advanced tab, OpenCL, and I believe that's everything we need for the time being. Okay, so we can really see what this is doing from a top-down view. Let's go ahead and just take a look at that motion right there. That's what the turbulence is going to do. It's going to twist around those voxel values. So that's great. That's exactly what I'm looking for. Let's also add just a general wind force going in a certain direction. So we'll create a gas wind right there. And let's just pretend that we have a slight breeze heading in the X, negative Z direction. So here's X, and in Z, maybe 0.5, 0.5, 0.5. Something like that. Okay, we'll add that in. Okay, and there we go. Now we have the smoke being pushed along with a slight breeze like that. If we want to, we can also add a bit of noise to this wind scale. So we can say motion effects, and let's go ahead and create a noise for that. So we'll say noise, the amplitude will be 1. And I believe that's all we really need. Just a little bit of noise would be good just to add some variety to that and make sure that it's not totally uniform all the time. Let's actually take this amplitude up just a tad bit, right around there. It's also going to help to have a little bit of this wind direction in the Y as well. So I set that to 0.25. And after doing so, if you take a look at a side angle here, we can see what that breeze is doing. Especially right around frame 70 something, it starts looking a lot more realistic. So there we go. I think this is looking pretty sweet thus far. I also think that it's going to help to turn up gravity a little bit. So let's try negative 12 on that gravity and see what that does. All right, so I turned up that gravity to 14 actually, and I found that 14 was a pretty good number. The smoke stays closer to the ground for the most part, but we still do have some of these plumes right here that follow the upwards winds, and I think this looks really cool. So we're going to keep that at negative 14. Now, for the gas disturb, we're going to use a block-based approach. And so for more information on this, check out my pyro videos. But basically, we'll say block-based, take off the threshold range, And then we'll say that our block base size for right now is going to be a value of 1 to start. Advanced, use OpenCL. Also, let's be sure that we are disturbing velocity. That's good. And threshold field is density. Okay, so with that being the case, we'll say that's going to be 1. This guy here is going to be, let's say, 0.25. And this guy is going to be 0.1. Let's go ahead and merge all those guys together. We'll attach that. And right now, with a strength of 1 across the board, let's see what that gives us. Okay, and now we end up with that going on. I do like the disturb towards the beginning of this simulation, but I don't like how blobby it gets towards the end. So right around here, I'm not a big fan of this sort of blobby shape that's getting created by the disturb. So perhaps the way to do this, or one way to do this, is we'll just animate that strength. So we'll say that from frame 30 to about 60, we're going to be at a higher strength, and then once we have 60 on, it's going to be much lower. So let's just start with this guy right here. Strength right now is 25. Set this to manual. Go to 60. Strength is going to then turn to 5. And we can just, it's probably easier to just make copies like this and change that element size again. So, or that block size. So 0.25 and then 0.1. Okay, let's see what that does. Okay, and after adjusting that, I scooted up the keyframe a tad bit. We end up with this. I think that looks much better. So, high disturbance, and then it kind of goes away right at frame 48. Okay, so I also don't like how far in the Y direction we're going, so maybe on this gas wind, I'll also animate the wind direction away from positive Y. So perhaps I like what's happening right here, but once we reach this, I want to start bringing that wind down. So maybe another keyframe here, and we'll set that to 0. And so now we end up with this. There's one more thing I want to talk about before moving on. That's going to be caching and being sure that you have the rest fields when you cache. On the smoke object, if we go to initial data, we have this right here called add rest field. We need to definitely check that. And then also go to the Pyro solver and find that here as well. So it's always a little tricky to find it. There we go. Advanced rest field, enable rest. Okay, so once we have those two things checked, then we go to the DOP import field. If you don't have this node, go ahead and make one. We're looking for this DOP nets. Right now we have density, but we also need to bring in rest. So let's just go ahead and actually do a preset for this. We'll just say smoke. We don't want velocity. We'll just say rest and density. For the object, we'll just say star. Also, this is really important. In this version of Houdini, so 18.5.351, these default presets are incorrect because it does not include rest 2. We need 2 rest fields, in other words, 2 positions, to switch back and forth in between in order for rest to work. So be sure you add in rest 2 right there, and then also set the visualization here to invisible. So once we have that, also go to the compression tab and let's compress density. So press the plus icon for fields to compress, say @name is equal to density, and check on this use 16-bit float. This will take your cache size almost in half by doing this. You'll lose some voxel data by doing this, but if you set up your shader properly, you won't be able to tell the difference. And this, again, will take that file size in half, so it's definitely worth doing that. I'm not going to do that for rest, but for density, that's going to be a good deal. Let's go ahead and cache this out as dust sim, and let's see what it looks like. So we have this play blast. I like the motion of everything. I like the timing, the pacing of what we're seeing. I think the next step here is to try out a test render. And along with that test render, in the next video, we'll also talk about rest fields and how to add a bit of detail via post-processing noise through these voxel values.